All right. Anyway, so why don't you quickly take a look at the cheat sheet or reference sheet I gave you. So what I want to point out is if you somehow understand, what vectors are, right? They are numbers, but they're more than numbers, right? They have directions involved. So what's really making it hard for you to to process or to play with them is the direction. But turns out that we have a very good form for you to even just imagine what the vector looks like, not to mention when it comes to add or subtract vectors. So this is the form that you should be playing with. And we call it rectangular form. Now, not every book call it, but trust me, this is not something I invented. And I wanted to call it rectangular form so they can see this is the same thing they've been dealing with in 7.3. So rectangular coordinates, right? Polar coordinates. So I hope that you don't end up learning anything new, or you find yourself learning something new, because you're not. Okay. For example, if you see a vector in terms of the numbers, right, and I and j, so do you remember what that -3 in front of I represents? That's the horizontal run. So the first number, the first component, right, whatever number is in front of I is the run, and the -3 means that it's going to right or left? Left, right? So now the number in front of j is the rise, which is a positive rise. That means it's going to go up. So now can you all imagine a vector with a negative rise, negative run, positive rise? What does it look like? Or which way it's pointing to? Top right, top left, bottom right. It's pointing to the top left, right? It's in the second quadrant, right? Because it's sort of going to the left and going up. All right, now what about the polar form? Now, polar form is talking about the length, the magnitude, right? And the direction in terms of angle. Once again, think about an arrow, right, that represents a vector with the length to be 5, but the angle is 127. Which direction you think that the arrow has to be pointing to? Top left, bottom left. Okay, it will be still in the second quadrant, right? So the top left. Go ahead. No. It does. If you're in 7.3, you know that the R could be negative, right? The negative is going to be like flipping things. So we'll get to that, tomorrow. So just in case that, well, I know that people will be coming for the quiz, but I do want to mention certain things, at least those things that bothers people the most. But right now, there's no point of getting a negative magnitude, right? So you pretty much just be looking at the angle. Now, which form you think that you're going to like a little bit better? The one with the length and the direction, or the one with the rise and runs? Rise and runs, right? And it turns out that you're so right, because later on, you're going to like to deal with that when it comes to add and subtract vectors. But unfortunately, you know that they're going to provide you the length and the directions in the test. Then you're going to have to write them in terms of the I and j, right? So now if you look down on the sheet, take a look at these two formulas. Have you seen them before? Back in, say, 7.3. Oh, I think that I need to... Am I recording this? I am. Okay, good. So yeah, my question is, have you guys ever seen these two formulas? They might not be written exactly like that. But did I put something like that on the board last week, right? X and Y and R and theta. So it's like, instead of calling it R, it's the magnitude of a vector, which is just the length of the arrow, right? It is the distance from the terminal point to the starting point. But at least that it looks just the same format. And that's how you're going to convert, which you will get to in a few minutes, to go from the polar form, magnitude and angle, into the rectangular form, which you're gonna love to deal with, right? When you add a subtract vectors. Also, what about these guys? You remember that, right? That is from the rectangular coordinates back to polar, even though that we call it R, but now it's just the magnitude of the vector. So that's for you to refer to, either now or tomorrow in class, or even if you're trying to homework. So always keep an eye on those formulas because there's only a couple of them, right? And I'm sure that if you use them for a few more rounds, you don't have to intentionally memorize them because they are things that you probably already know. All right, so now let's just get to those problems for our test review. But I need to make sure that you guys are aware of, since whoever made the test already sent us a updated version of the test review packet. But it's not something like, they're adding ton of problems because there were multiple packets. So the person just, combined these problems. So I want to make sure that you guys are able to find it. So if you go to, the course, D2L, right, go down to content and find the module all the way down, right above the final exam review. So there's the module that says test 4 practice, right? So if I view as a student, so you should be able to see just one packet, okay? And that's the one we're using today. But you know that this packet has 70 questions, but again, the good news is it has a lot of questions about 7-7, and it's not going to be covered on the test anymore. But the issue is they scramble the questions, so I couldn't tell you exactly which number unless I just look them up. I'll try if I could, right? But if you were to just go with the questions that I'll be pulling to show you today in class, right? Take pictures or ask for the notes. So those are the questions will be only about 7-6. And if you can be coming, hopefully before Wednesday to get your quiz done, that means you should be ready for the topic from 7-1 to 7-3. So there's not too much you have to worry about, okay? But let's make sure that you guys are definitely ready for questions at the test level regarding the vectors, which is 7-6. Starting from this one. So they told us about the vector in terms of the rise and the run, right? So first off, which quadrant do you think that the vector better be in, given a positive run and a positive rise? First, right? You see that it's not going to be A and B, so it has to be those two guys, right? But do you see that they wanted to also find out what the double bars enclosing the V, but what is that? What does it stand for? Magnitude. How do you get a magnitude? Say for this arrow, if I know the run is 9, the rise is 12. How do you find the length of the vector? That's the right triangle. Don't you just use the Pythagorean theorem? Yes. So the magnitude is square root of 9 square plus 12 square. Don't forget to take a square root, right? So you're going to get 15. Therefore, C is correct. It's 225. I don't know how they get that number, but that's a subtraction. Right? So do you see how straightforward it is? If you have a vector that's so easy to imagine in terms of the rise and run, right? The rectangular form, and you can easily extract the magnitude out of it. Okay, if you want to do that. So now, why don't you guys try 28? I know it's kind of small, so let me at least show you the options. All right, 3i, 5j. Okay, so the vector v that you're working with is 3i minus 5j. Go ahead. Have your calculator ready, right? So plug in that, get the magnitude workout, but keep an eye on the quadrant. is it letter B, right? You guys all get that? Well, first off, why it has to be in the fourth quadrant. So it's a negative rise, right? So it's going down and a positive run. So that means it has to be in the fourth quadrant. Then you do the Pythagorean theorem. So it'll be square root of 3 square plus negative 5 square. And it's going to be square root of 34. Okay. That's the level and the style of the question. And I will say that it's probably the same exact wording because that's straight from the same question bank. Okay. Now, so now what about you guys need to realize we try so hard to prepare you for the test by showing you the kind of questions in a test, right? Or could be in a test, but you do have to read the instruction in the test, right? Don't just look at the number and try to guess what you're supposed to do. Read the question. Let V be the vector from the initial point P1 to the terminal point P2. Write the V in terms of I and J. So if I plot the 2 points for 54, you don't have to do that in the future, but at least let's do it once forever. So P1 is 1, negative 6. This is 1, right? That's something like negative 6. So that's P1. So P2, negative 1 and 4. Okay, so negative 1's here, right? 4, something like that. All right, that's P2. But they're asking you to find out that vector V, if you want to draw an arrow, it starts from P1, ends at P2, right? And let's call it V. How would you put that in a IJ form, like the rectangular form? What number goes in front of I? And what number goes in front of the J? The X and Y, right? Would you be able to read it off from the plot? So the order make a difference, right? So it's always the terminal minus the initial. You start from P1, ends in P2, right? Take the final or the terminal coordinates minus the initial coordinates. So then we're going to do negative 1 minus 1, so you get negative 2. And that's the number in front of I, right? That means, you're looking at negative 2 units of run. Then now you guys tell me what will be the rise. To go from negative 6 to 4, so 4 minus negative 6, that's 10. Okay, that's it. But oh yeah. Well, whatever concerns you have, better let me know now. So now it does make sense, right? Negative rise, that means negative round, that's pointing to the left, and it's going up. But what if, forget about the 2 points. If you're given a vector like that, how would you actually plot it? Would you let the vector that starts from somewhere down below? I mean, why would you do that? Start from the origin, right? See that negative 2 tells you that it's going to go to the left by 2 units. 10 going up, right? Would you say that it will be a vector? Oh, come on. Oh, the layout, the new keyboard is just bothering me a lot. You don't have to be sorry for that. Now, well, I wish I could draw the arrow a bit longer. But do you guys see that if I were to draw the 2 graphs in the same scale, the arrow is going to be the same length as that one, right? They're pointing the same direction. So they are the 2 exact same vectors. But this is a lot nicer since it starts from the origin. This is like if you start your field trip, right? You can leave your house, right? Go straight to the destination, or you can leave, the school, right? But wherever you're gonna leave, or whatever will be the starting point, you can put that at the origin. You decide where the origin is, right? But this is a way for them to tell you the starting, the end point, that this is a home, that's a school, right? And that's how you go from home to school, right? Straight ahead, right? If possible. But I'm telling you that this is the standard position of a vector, start from origin, okay? So now you guys go ahead and figure out what 55 is. So you already figured out? But turns out that both those problems, you better spend no more than 1 minute to get them done if they're in a test, right? Because you could do the mental math, right? Just P2 minus P1, right? -3 minus 2, you get -5, right? -5 minus 2, you get -7, right? That's it. All right, so now let's see those questions. Again, let's read the instruction first. Write the vector v in terms of I and j whose magnitude and the direction angle theta are given. Now, for those questions, would you say that they gave us the polar form? Polar form are the length of a barrel, the length of a vector, right? The angle, but they want us to write the rectangular form, right? How do you do that? Why don't you take a look at the fifth line, right, for the equation, where it says x equals the magnitude of the v cosine theta, y is the magnitude of the v sine theta, right? So this is like converting, just like back in 7.3, converting the polar coordinates as if that r is 10, theta is 120, back to x and y. And a way to do that, well, of course, I'll try 46. I'll let you do 48 later. So 46, given the magnitude and then the angle, x, the horizontal run, right, is the magnitude of the vector times cosine of the angle. So that will be 8 times cosine 180, whatever that angle is, put it in, right? If it's positive or negative, it doesn't matter. Just make sure that you put in exactly the same angle they told you, but you do have to respect if it's radians or degrees. In this case, it's degree. Now, if you do type of everything correctly in a calculator, make sure in degree mode, cosine 180 degree is -1. So that would be -8. Y is the magnitude of the vector v times sine of the angle. All right, so 8 times sine of 180. Now sine of 180 is 0, so the y is 0. Now, how would you write the vector in terms of I and j? It will be whatever the number for x, right? Put it in front of I, but that's indeed -8 times I plus 0 times j, but no one's going to put 0j, right? 0 times anything is going to be 0, right? That means you will just leave it as -8j, -8i. So that will be letter C. Now, does it make sense? If you're looking at a vector with a magnitude, oh, you guys need to go? Go ahead. So the magnitude is 8, but the angle is 180. In what direction do you think that this vector has to be pointing to? With the angle to be 180 degrees. So straight to your left, right? Now, does it make sense that a vector has a negative run, no rise? It will have to go to the right, right? See that everything get together pretty consistently. So now you guys try 48. 48, yeah, go ahead. You done? Next. Hold on. All right, so go check your work. You compute the x and y the same way, right? Now, please, if you're getting negative from the calculator, because cosine 120 has to be negative, right? Keep that negative sign, right? And the y, 5 radical 3, you can see that A matches what we got, right? All right. Now, so far, you see that we've been playing with the polar form, right, which are the magnitudes and angles. Rectangular forms are most likely what you want to be in, right, at the end, right, n and j, right. You can go back and forth. You can even read off, the quadrant, right, the angle. Qualitatively, but we'll get to, the detailed calculation of an angle. But you know that what actually hurt our students, for the most of the time in the test is, word problem, right? Even though that I could ask you to do the same exact calculation, but it was hidden, behind a word problem, right? So that's making it a bit harder. So now why don't you take a look at 44? And now you can even see from the options, right? So they're asking you to find out the rectangular form of a vector. But instead of telling you what the vector is, they say a child throw the ball, right, at the speed of a 9 and an angle of 63 with the horizontal, right? So I really suggest you to do is to draw a sketch. I'd say a ball, right, get pitched into the air. The speed is 9, right? The length of the arrow is 9, and it makes an angle with the horizontal direction, so that will be 63 degree. But isn't that just telling you the vector v has a magnitude of 9? Angle would just be 63, right? Yeah. You know how to get the components, right? X is 9 times cosine 63 degree, and it turns out it's going to be about 4.086. If you do the y, it will be about 8.019. Okay, so that would be B. Right? Not too crazy, right? It's just you have to calm down and read through the question and get those numbers. Make sure you understand that 9 is just a magnitude. The angle is 63. Okay. Very likely it will be a multiple choice like that. Oh, there will be something like that as a response, but it needs to have more student work because for the problem you just saw, right, there's not so much work you can show me. I don't get to make the test. Now so just now I was asking you guys, whichever form you like better, is the polar form or the rectangular form. So now when it comes to adding or subtracting vectors, you must, that's not an option, you must write the vectors in the rectangular form. If you're wondering how to do that, well, the questions we've been playing so far are telling you how to write the vectors in the I and J, right? the rectangular form. So now take a look at letter 51. So 51 is asking you to add up the u and a v, right? So I'll write it out. U plus v is, in terms of I and j, u is negative 12i minus 5j. Okay. Now the v is 5i plus 8j. So without me telling you anything more, at this point, what do you think you should do just to make it a bit simpler? Say it again. Make them P2, P1. Oh, you're looking at the points. Well, that will help you if you want to visualize it. But let's say if I'm looking at just some algebraic expressions, right? Do you notice that the first term, the third term are sort of like the like terms? Like you don't worry about the I and j, they're just letters, right? So you have negative 12 times this guy plus 5 times the same guy. So if you were to just combine these two like terms, what do you get? Negative 12 plus 5 together, right? You're going to put the I right next to them. Now what about the j's? Again, you combine the like terms, right? So you're going to add up negative 5 and an 8. Put the j, right? So the numbers add up to be negative 7i and positive 3j. That means that once you add up these two vectors, it is still a vector. And it's now in a form of the rectangular coordinates. And that matches letter B. But you don't really have to write them out. Do you see what has happened? The two vectors add up in their components. You see that? Their rounds add up, negative 12, 5 add up to be negative 7. Their rises add up, right? Negative 5 and 8. So that means you could have just do the math right away. Negative 12 plus 5, you get negative 7, right? Negative 5 plus 8, you get 3. But what I'm showing you is, if you just bluntly write them down, you see how nice those I and J forms are, because they actually add up as if they're polynomials, right? But I think that you're better off just to think about the x and y, right? X add up, y's add up. So now what about 53? Go ahead. $17. Now, the reason why you are getting negative 17 or 17 is you were subtracting the two vectors, right? But you're adding them. So you add up the rise and run and subtract, right? So now, but you're going to do the subtraction now. Go ahead, guys. Work out 53. But be careful with the order in a subtraction. And also be careful with the signs, right? You know, when subtracting the negative number, right? 53. Yeah. Right? So, well, some already figured out it's letter D, right? Does it make sense? U minus V, well, you just subtract those guys, right? Negative 11 minus negative 6, so that's negative 5, right? Negative 2 minus 7, negative 9. That's all. But what about the question 52? They want you to find double bars enclosing U plus V. I mean, what is that? Of the sum of U and V. That means you should add up U and V the way we did, then find the magnitude of it. So let's do that. So U plus V, 52, right? So U plus V. So I don't even have to write out the work. I know that negative 9 plus negative 10, so it will be negative 19 I The j's 1 plus 1, so 2, right? So now the question is, how do you get the magnitude of the vector sum you just figured out? Just do a vector. So, well, again, the Pythagorean theorem, right? Square root of -19 square plus 2 square, and it's going to work out as negative, not negative, sorry, radical of 365, right? And that's letter B. How's everything so far? Not bad, right? So the only trick you end up doing is just taking something, might apply, multiply sine theta, cosine theta. That's all. Okay, so now turns out that you're gonna be doing things like that, but the vectors might not be ready in the rectangular form. Not to mention that they will tell you the vectors in a word problem. So you have to extract those information and get them ready so then you'll be able to add them up, right? And this is definitely going to be a word problem. And it's going to be FRQ. All right. So what I'll do is I'll work you through in detail, 37. So I want you to see how that works out so you can see, things are still the same as before, but, how do we get ready for everything? No, that'll be for you to give it a try. I do the easy one, then you take the hard one. Isn't that nice, right? All right. Now, so 37. So the two vectors, I mean, you're not taking physics right now, so you don't have to worry about what they are, but they call it forces. But you know what? If you be taking physics next year, the first 2 chapters, 2 or 3 chapters, you're going to get motions, you're going to have forces, right? A lot of the hard questions that usually people drop out due to those questions are like that. That means, if you're already getting this math, and, in the future, you shouldn't worry too much about those notorious calculation in physics that scare people out, within the first couple of months. No, the first couple of weeks, because college, they go fast. So let's make sure that we can visualize what those two vectors are. So we're ready to get their components or the rectangular forms. So this is north, that's east. So I have a vector F1 with a magnitude of 60, and the direction is the bearing north 40 east. So this is what the direction looks like, right? So let's say this is F1. This is 40, right? See, north, east, right? So start from north, turn to east by 40 degrees. Now F2, north 40 west. So it'll be on the other side. That's F2. That's 40 degrees. So given their magnitudes, would you say that they're telling us the polar form? You know what? If you don't want to confuse you, so let me make sure that that's the diagram. All right, so we know from the problem the magnitude of F1 is 60, right? The magnitude of F2 is 70. Okay, but my question for you, what do you think will be the angle associated with the vector F1? The angle that we use the whole time for the calculation, sine theta, cosine theta. So for F1, would you just take 40? Why not?
Like the angle 40 line on it. Across from you.
Or Max, can you remind us, how do we measure an angle in a standard way? We should always start from yeah, and the initial side of angle has to be the positive x, right? Then you either turn this way or that way to get either positive or negative angle. So the angle associated with the V1 of F1 is turn here, going all the way to F1. So it's that angle instead of 40. But how much is that angle? The complementary, right? Which is 50. Now you guys all see this angle, theta 1. Say it again. Because let's see where it is. No, I'm glad you asked. All right, so let me make sure that oh, come on. You know what? I couldn't even find it somewhere. Anyway, so by convention, when we say the angle for a vector is always the same exact angle that you're getting even in 7.3. The angle theta is always starting from the positive x, turning one way or the other. So you never measure the angle from the y-axis. Okay, so now what about the angle associated with F2? Where F2 is actually in the second quadrant. You still start from the positive x, turn, that's 90, keep turning, right? So that'll be 90 plus 40. So it'll be 130. So if you don't get those two angles correctly, then the math is not going to work out. And you know they're going to have those options that assuming that people's going to get the wrong angle, right? So now the rest of the work is, you know, pretty straightforward. So I'm going to use x sub 1, which stands for the rise for F1, and that will be the magnitude 60 times cosine of theta 1, which is 50 degree, right? If you work it out, you know what? I wish I have. Okay. So cosine 50 times 60, so you get 38.56. So y1, so that's the rise of f1, so it'll be 60 times sine 50. All right, so it'll be that's 45 point, oh wait, yeah, 96. So we'll do the same thing for the f2. That's x2, right? So it'll be 70 times cosine of 130 degree. It'll be negative, right? Because cosine 130 is negative. So that's about negative 45.00 because I rounded up. Now for the y2, that'll be 70 times, times sine of 130. Okay, so it'll be 130 times 70. So that's 53.62. Yeah. Okay, so now what they're looking for, check this out. They have a fancy term for it called resultant force. So the word resultant is basically the result, right? So how do you find the result of the two vectors sort of added up, right? So basically the resultant force is the sum of the two forces, sum of the two vectors. We know that you cannot just add up 60 and 70. You should add up their rise and runs, right? So let's say F1 plus F2 in a vector way should be some numbers, right, in front of I, some other numbers in front of J, right? How do you get a number in front of I? Add up the x's, right? So it'll be 38.56 plus, oh, actually minus because it's a negative 45, right? So minus 45. Now the y's add up, right? 45.96 plus 53.62, right? So you work it out. What is that? I think it's negative 6.40. Is that 44? Am I doing it right? All right, so 38.56 minus 45. But yeah, 6.44. I plus 45.96 plus 53.62. All right, so that's the vector sum in terms of the rectangular form. But you see that those questions offer you not just I and J, right? But the magnitude and the direction. Magnitude is pretty straightforward, right? If you just get the magnitude from the I and J by taking the square root of negative 6.44 square plus 99.58 square, and you'll be getting 99 point something, because I've tried it, already with the first two classes, right? So whatever that is, close enough, right? But now here's the angle that will confuse a lot of people. Now, why don't you take a look at the formula at the bottom of the cheat sheet where it says going from the rectangular form to the polar form. Do you see the way to get the angle is to take the arctan or the inverse tan of the vertical rise over the horizontal run. Okay, but if you do that, 99.58 over negative 6.44. Okay, so that will get you. You take a look at there. So negative 86, approximately negative 86 degree. Okay, so now remember the magnitude is something like 99 something, right? The angle is negative 86. Do you see an option that matches that? Well, at least there you have letter A that's matching the magnitude, right? Close enough. But why they're getting 90 something degree, but I'm getting negative 86? So we're looking at a vector with negative wrong, positive rise. Which quadrant should it be in? Second quadrant. But what does it tell me if you get an angle of negative 86? It's in the fourth quadrant, right? You know that the subtlety, if you remember in 7.3, subtlety comes from the inverse tangent is it might be off by 180 degrees. Not always, but sometimes. So now you know that if it has to be the second quadrant, you would add 180 to that to bring it to the second quadrant. If you add 180 to negative 86, you are getting 84, right? Which is exactly what they got, right? 93.7. But that's not going to be a multiple choice, right? So make sure you know that there will be traps, right? Not as many as you thought, but you do get that from the inverse sign. You guys remember that inverse sign? You get the angle. It's going to be either the angle or it's supplementary. You're going to have to look into both possibilities. Inverse 10 angles might be right, but could be off by 180.